Hello guys, today's lecture is going to be about the switch, the basics of Cisco switch, and these are the topics we are going to cover. What is a Cisco switch? What is the job of the switch? Actually, what are the main jobs of the switch? Switch can do a lot of things, but what are the main important job of a switch? And how switch able to do all these things? In short, how switch learn about the end devices and how it operates and how they make communication happen between them. What do you mean by end devices? End devices mean your PCs, your printers, and your laptops, even. All the devices that are used by the end user. And what is the difference between layer 2 switch and a layer 3 switch? Okay, this is a little bit advanced, and these are the most basic things. If you know all these things, then only you will be able to understand what is the difference between a layer 2 and a layer 3 switch. If you know OSI, in the OSI you have to know the OSI model in order to learn about the switch and all these topics. Okay, so I will put the link of how to learn about the OSI model, what are the layers, into the link description. Because in the OSI you have layer 2, and the layer 2 deals with MAC addresses. What is MAC addresses, how they looks like, watch the OSI video. MAC addresses are actually physical addresses, and they look something like this. I am just giving you a random example. They are 48 bits, and in short you can say simply 12 characters. 12 characters hexadecimal, because these A, B, C, D, E, F are hexadecimal. The numbers are going to be from 0 to 9, and then instead of 10 you have A, then B, then C, then D, then E, then F in the MAC address. So MAC address is going to consist of all these digits. So layer 2 is data link layer. MAC addresses are learned, meaning everything, every communication, where to send the data, from where I am receiving the data, is according to the MAC addresses. And the switch that works on MAC addresses are known as layer 2 devices. And layer 3 devices, because layer 3 is the network layer. And network layer, at layer 3 you don't have MAC addresses, but you have some other special addresses, which is logical address, and you know them as IP addresses. The logical address, example, for example, 192.168.5.1, it is just an example. Or you can even have 2.3.5.6, or you can even have 8.8.8.8. This is physical MAC address because it is burned in, it is written on your hardware. And this is logical address because it is assigned to your device either automatically or either manually by you, and if you want you can change it anytime. MAC address will be there on your device. Okay, IP address is a logical name of your device onto the network. Okay, so layer 3 switches have the capability to listen and learn and forward on the basis of IP addresses. And as you might already know, layer 3 device, the routers, Cisco routers are layer 3 device. So the layer 3 switch which can understand and learn on the basis of IP addresses will act as routers. So in short, layer 2 switch is just a normal switch who work on MAC address, and layer 3 switch is a switch which has the capability of acting like router also. It can forward traffic on the basis of IP addresses. So let's move on. So what is a Cisco switch? Basically, when we are talking about switch or normally Cisco switch, then mostly you mean the layer 2 switch only. Even if you study in your CCNA, basic networking device, and somebody says Cisco switch, by default you mean layer 2 switch. Okay, and if you are saying especially you want to mention layer 3 switch, then you will be saying that what is layer 3 switch, or you can also say MLS, multi layer switch. So you can have a layer 2 switch, layer 3 switch. But if somebody is saying I have a Cisco switch in my network, I have some end device, so they mean by default you have a layer 2 switch. Okay, so let's see how a layer 2 switch looks in your GNS3. So GNS3 is a very powerful simulator. So if you don't know how to set up the switch or the GNS also, I will also put these links. So I'll put the link of the OSI as a prerequisite. If you already know, it's okay. If you want to revise or if you don't know, go watch the OSI and then watch the link of basic GNS tutorial and then watch how to set up this GNS switch to get the CLI, because if you install GNS you will not get this switch, nothing will be there. You have to learn how to install VMware and how to integrate the file so that you can finally enjoy the CLI of the switch. So you just click here, drag it, drop, and you have your switch in front of you. If you want end device, click on this PC icon and you have a lot of VPCs. And as we are using GNS3 VM, you will just click here. What is this VM, what is this switch and all? For that you have to watch the video regarding the switch integration. Then drag the other two PCs, because for our topology we need at least 2-3 PCs. So let's take 3 PCs. Okay, and let's connect these to our switch. And as soon as you connect, you will see the red light, because the red thing is nothing but it says that your device is powered off. Is powered off. Okay, so we'll just put it here. PC1 we have, PC2 we have, PC3. So basically if we talk about a switch or a layer 2 switch, the job of the switch is to create a network. What is a network? A collection of devices. You will take the end device, you will connect them with the layer 2 switch and the communication will start happening. And as a networking guy, as a network admin, as a network support engineer, as a network XYZ, you have to know how switch works. Then only you can create such network, then only you can troubleshoot some network if some problem comes. If you don't know how the data is going, how switch is reading them, storing them and forwarding them, then you can never troubleshoot. If you have to know all the things how switch acts. Okay, and switch is pretty much straightforward when it comes to your basic forwarding when compared to routers, because the biggest difference now I'm going to tell you between switch and a router. If you take a router here, this is the most like for layman. The difference is I'm not going to go into MAC address and IP address and forwarding and routing table and MAC address table. No, for the simple, like even a layman who don't know even IT technology will understand a difference between a router and a switch. If you take a switch here and if you put it here in between and you connect the wire and you turn on the power, all three PCs can communicate with each other. And if you put a router in there and if you do the same thing, you turn on the router, you turn on the PCs, then the PCs will never ever communicate, because you have to put the IP addresses, you have to do some configuration onto that. Why? That's how router works. Okay, why? Because for that why there's only one answer: CCNA. Okay, you have to go and study CCNA. Okay, and if you want to know the difference, that is the difference between switch and the router. Apart from that, there are many difference. What is the another technological difference? Layer 2 and layer 3. But someone can argue with that. Why? Because what if it is a layer 3 switch? If it is a layer 3 switch, it can also do routing also. So what is the job of router then? So that is out of the scope of this video. What is router and how it performs? So we are not going to discuss anything about it. We are only focusing on switching. Okay, as switch and routers are termed like they are mentioned with each other, so I just told you the difference between these two. And now on every PC, because see PCs we don't talk about much, what we are going to have, we are going to have some IP addresses and some MAC addresses, nothing much. So how forwarding will happen now? The question is on the basis of IP address or MAC address. That is the question. So I already told you that layer we are using. I told you we are using a switch. So if I told you we are using a switch, it means we are using a layer 2 switch. Okay. And just in case, just for information, in reality this is not a layer 2 switch. This is a layer 3 switch. But by default, if I haven't done any configuration or anything on this, then this device will be acting as a layer 2 switch only. In order to make it act like a layer 3 or a router, I have to do some special command on the ports. So I haven't done anything, so it will be acting just like a layer 2 switch. Also these PCs are going to have some IP addresses that we are going to assign and some MAC addresses also. But first thing first, in GNS you have to turn on the device. So just click here and all the devices will be powered on. So let's one thing, you cannot see the interfaces. For this practical you don't need that, but if you want to see to configure on the IP or something else, then you have to have the interface information. For that, just click here and you will see all the interfaces. Just arrange them so it will look more clear to you. So double click on any device. If it is green, CLI will come up. So for PC1, the syntax to assign IP address is IP 192.168.1.1, 255.255.255.0. That's it. That's how you assign IP address. Okay, so now in here I'm going to show you something. Okay, so please pay special attention. I'm going to do a weird experiment so that you can learn switching, not the pretty much straightforward way. Because straightforward way you can just open Wikipedia and you can read there. What I did just now, I assigned the IP on PC1, but I haven't assigned IP on PC2 and PC3. So let it be like that. What our case is, let's put a take like IP is check. Okay, in here no IP, but all the PCs, if even if they don't have IP, they have MAC addresses. So I want to know what is the MAC address. The command for that, show IP, let's do, this is the MAC address. And be aware that even if you go to your real laptop, you cannot do this command. This is my real laptop. I will go to run, I will go to CMD. I want to see my IP, MAC and everything. For that, the command is ipconfig/all. It will give you all the things, IP address, MAC address and everything. But in GNS we are not using a real PC, but we are using a VPC. For virtual PC you have to learn some specific commands, and by specific I mean only two commands will do the job: how to assign IP and how to see IP. That's it. So take that MAC address, and if you can count, there are 12 digits in here. So select and just paste it here. Okay, and let's go to PC2. PC2 don't have an IP address, so let me show you that also. Show IP, and there is no IP address, nothing you can see, but always the MAC address is going to be there. And if you are curious and if you ask what the hell is this thing, only one thing for you: don't look there. Okay, because how these VPCs work, what are the like complexity behind them, it is for that. What is for us, these all things are for us. So let's go for PC3. We don't have IP, but we do have a MAC. So let's copy that MAC. And why we are so bothered about this weird MAC? Because we are using the switch. If you are using router, you will all be talking about what is the IP address here and there, only that. Because router will look at the IP address and forward the traffic. And that table has a name. What is the name of that table? Router has a table. When any traffic comes, router look at that table and decide where to forward the traffic. For router, there's a command for that. What is the name of the table? Can you tell me? Routing table. Okay, and the command to see the routing table is show IP route. So if you do show IP route, you will see the routing table. Okay, forwarding happens on the basis of routing table. Now routing table, is it constructed automatically? No, we should do something. And what we should do? Yes, a lot of commands. In short, we have to do routing. You will do some routing protocol, you will do static routing, RIP, IGRP, OSPF. These are the protocols. And then after that, after all that hard work, your routing table is constructed. But for switch, you don't have to do a single thing. You just have to turn on the devices, connect and send some data. Because when you send some data, the switch will automatically construct his own table, and the name of that table is MAC address table. And in that you will be seeing a lot of entries. What are the basic things to look there is what is the interface, what is the MAC address, and also what is the VLAN. VLAN, just leave it for now. So interface, for example, after everything is successfully done, we might see something like this. On E00, we have a MAC address, and then that MAC address is this. For E01, my own interface, I have some other MAC address. And if this table is there with the switch, then switch can forward the traffic very easily. I told you that you don't have to do any magic, any command, any protocol to construct this table. This is the MAC address table of the switch and it is constructed automatically. So let's see how it works. We have all the devices, they are powered on, everything is there. So let's go to the switch and check, or PC. Let's be there. We can do one thing. Let's imagine you have PCs in your network and you just put a brand new switch, because see, I am simulating a real lab. So in the real lab you will be having your three PCs working. What do you want to do? Either you want to share some file or movies, or you want to play some game on LAN. For that you also need a device. So switch is very good option for that. If your switch is set up, you can easily play Counter Strike or anything here. Okay, so you bought a switch, you are very rich, you bought a Cisco switch. Okay, so you right click and you started it, and then only you can take the console by double clicking on the device. And this is how a switch looks like. In the beginning it will tell you a lot of things, especially the company, okay, where it is located, even the address and the phone number is there. Why do you need the phone number and the address? Because if your device is under warranty, you are going, and if you are having any issue, you are going to call Cisco, and there one tech engineer will handle your case, that how to solve it. That's why Cisco is giving you all these things. Okay, so and the copyright and all lot of things are there. And apart from that, we'll be having the how many devices we have, how much RAM we have, what is the processor and all version and all things, what is our iOS version, what is the file that it is booting from. This is the file it is booting from, and this is the iOS version that we are using. How many ports I have? I have 16 Ethernet interfaces. I have 16K of NVRAM. All these things. Okay, so the CLI is pretty much similar to router, not pretty much exactly similar. The modes and everything. Commands will obviously be different because it is a switch. Now, I want to see the MAC address table. The command is pretty simple. Just put a show in front of it, and you will do show MAC address table. That's why I put a dash in between. Just put a show in there and you have yourself the command. Now enter, and it should be there. Okay, I told you, see, don't care about the type or VLAN. On what port I have what MAC address, that is all you need to know. But this table is not constructed because no communication have happened yet. So how it works, when the communication will happen, if any packet or any data is received on the port, the source MAC address will be written by the switch here. For example, I just sent any data. I just went to PC1 and I will do some sort of ping, and I will say I want to ping 192.168.1.2. So is the very first packet that will go out PC1, is it the ping packet or something else? It is not going to be the ping packet. It will send the ARP request first for the MAC address of 192.168.1.2. And you see, the thing is, it will first check whether I know this guy or not. Do I know his MAC? No, I don't know his MAC. He is unknown to me. I'm just a brand new PC. You just turned me on. I don't know any MAC. So what will happen? It will generate a ARP request, and in that ARP request, I will ask simply what is the MAC of 192.168.1.2, and this is the message that I am going to send. And in this message, okay, so bear with me. Okay, so bear with me. I have to make it a little small because I'm going to give you a lot of info here. It will send a ARP request that what is the MAC of 192.168.1.2, and see, this is the packet. But with every packet you have to have a source IP, destination IP, source MAC, destination MAC. There is the old story, especially that you will learn in depth in the OSI. It is just like the summarization of OSI. How communication happen? Whenever any packet goes, you have to have a source IP, a destination IP, a source MAC, a destination MAC. So if you are not very clear with the ARP protocol, or you don't know what is ARP request, it is good for you, because I am going to tell you all these things. Because the PC generated the ARP. and because of that R packet only, the switch will learn the MAC address. What MAC address precisely? The source MAC address. Because see, in the source IP I will simply say I am 192.168.1.1. Destination IP is 192.168.1.2. Source MAC, because every PC knows its own MAC address. So my source MAC is this. What is my destination MAC address? Can you tell me? Any of you? We have some offline student also today. So tell me, what is the destination MAC? Any idea? In the ARP request. 0.0.0. Okay, so see, it is like common sense triggering in. Half of the people watching the video might be thinking that destination MAC is going to be either this or something like that. But the question is, if you already know this MAC address, then why the hell are you sending the ARP request? Because on the ARP request, we are saying what is the MAC of this guy, and if you are putting that MAC, there is no need of sending the ARP request. You are sending the ARP so that you can know this MAC, so that you can generate the ping packet. So that's why pretty old basics ARP request is always a broadcast. So that's why you will have a special MAC address which is of 12 digits, and that is known as the broadcast MAC address. 1 2 3 4 5 6 7 8 9 10 11 12 we have, I guess. So this is your broadcast MAC address. Why? Because as soon as the switch will receive this, he will know it is a broadcast and he will send this packet to everyone. Now, even before that, pause this packet, this whole packet ARP request will go to the switch. And what will have 1 2 3 4 5 6 7 8 9 10? Okay, I think I went overboard. 12 only. Okay, so if it go there, the switch will receive the ARP request, and switch will like just contemplate that I received some data from some device which have a source MAC address, and it is my sworn duty to learn about the MAC address because I'm created for that purpose. My job is to learn MAC address. That's why read here. Listening for the packets, frames, data, and learning what? CCNA? No, learning MAC address. And then later on only I can do forwarding. If I cannot do these two, I can never do forwarding. So listening, it will listen and it will look for the MAC address in the source, and it will learn that. What do you mean by learn? Learning simply means I will take the source MAC address, this one, and I will put it into my MAC address table with the port on which it is received. So I received a MAC address on E00, so I'm going to put that MAC address for that particular entry. So in short, if we ping do this, we go to the PC right now, then we should have seen this entry. And when the packet will go from PC1 to here, then PC2 is going to respond because ARP request is a question. What is the MAC address of 192.168.1.2? The PC will say the MAC address of 192.168.1.2 is this 666800 this, and in that ARP reply he is going to put his own MAC address as source. So when he will send the ARP reply, the switch will also learn his MAC address and put that entry on E01. So he will send the ARP request. See, you can replace ARP request or ARP reply with any packet. Whenever switch receive any packet, any data, it will put the source MAC and the interface and put that mapping entry into the MAC address table. This is the normal thing how switch works. Okay, but in here we cannot do this. Why? Because PC1 have IP address but PC2 and 3 don't have. So I am going to do one thing. I am going to PC2 and I am going to give the IP address. But before that I want to show you what is the case on my switch. Do we know any MAC address? No. We don't have any MAC address because no communication happened. No, we haven't sent any ping, any ARP, any data. That's why our no listening happened. So no listening, no learning, nothing. So now I'm going to go to PC2 and I'm going to assign IP. Not ping, but I'm going to assign IP. It can be your printer, your PC, your laptop, anything. 1.2. And one very weird thing is going to happen now. Not here. I assign the IP I haven't done any communication. I'll go to the switch and I will do show MAC address table, and look what just happened. Magically, without you doing anything, the switch automatically learned the MAC address of the guy on which you signed the IP. Port E01. We don't care about the IP, we care about the MAC. On E01, he magically learned 796668. 796668. Automatically that MAC address. Why? Because according to our theory, our imagination, the switch is supposed to do that only when you assign, on only when you do communication. Then it will learn. When somebody will talk to someone, then switch will learn the MAC address. But we just assign the IP. Can you tell me why it happened? What ARP? Why we see PC? We never send any ping, so we never sent any ARP request. There is one special thing, one special packet. See, the thing is, see, sin you might say sin, synac or something. That only happens with the TCP. We are not using TCP. Actually, we are not even using ICMP. We are just assigning IP. If you do some TCP communication, yes, you are right. Synac will happen for TCP. But we are not doing that. We are just doing the normal IP address assignment, and automatically the MAC address is being learned. So what happened when you assign IP address to any machine? Any machine. It can be your laptop, it can be your PC, it can be your router even, it can be your even your smartphone. I'll just write mobile. Okay, it can be a tablet, pretty much the same thing. When you assign IP, what IP? Let's say A dot B dot C dot D, then that device will generate a special R packet, and that packet, no, and that packet is known as, I am not going to write the full thing, is known as gratuitous ARP. Okay, that thing is known as gratuitous ARP. In a lot of the places you might have heard that thing with gracious ARP. Okay, actually gracious ARP is the wrong spelling for that. Okay, you don't even spell it like that. It is gratuitous ARP. Okay, so what is this gratuitous ARP? Its job is to find for any duplicate IP, because in a network you cannot have duplicate IPs. You should not have that. But how your PC is going to know if you have any duplicate IP or not? The answer is the gratuitous ARP. How it works: when you assign IP, the ARP packet, the gratuitous ARP goes and it asks what is the MAC address of my same IP, the IP that is assigned on me. Now you might be thinking, is my device, PC or laptop, is drunk or what? He's asking my own MAC address. He already knows what is my MAC address. For example, replace it with our case 192.168.1.2. He is asking what is the MAC address of 192.168.1.2. But the thing is, he already knows his MAC address. So why he is asking? He is actually pretty smart, because you are never supposed to receive the reply of this ARP request, because it is your own IP. And in some case, if somebody send you an ARP reply and he says that the MAC of 192.168.1.2 is something XYZ, then immediately error message will come to your log and it will say duplicate IP address or IP address conflict, because you were never even supposed to receive the reply. And if you don't receive the reply, nothing will happen. It's just like a check. And now I'm going to show you the check on the live device. Why? Because I'm going to do the same thing on PC3, because PC3 as of now don't have any IP address, and I'm going to assign the IP address and get it to us R packet will go. But how I'm going to show you, there is a very powerful tool known as WIRESHARK. Okay, so I'm going to capture the packets. WireShark is a very captured powerful tool which will capture the packet and show you on the interface what packets are traveling. When you turn it on, you might see some packets already going on. So don't get scared, because see, PCs, routers, they send a lot of packets. We don't care about that. Right now we care about gratuitous ARP, or I am going to just say GR for now. Okay, so we care about that special GR, how it looks like. Okay, so let's go to the PC3 and see that the half part of the story. When that gratuitous ARP goes, it looks like this. What is the MAC of 192.168.1.2? And in the source IP, I will be having my own IP address. In the destination IP, I'm going to have my own, because I'm asking my own MAC. Source MAC is going to be my own, and destination MAC, as always, it is a ARP request, is going to be 12 times F. So when this gratuitous ARP will go, then I will copy the source MAC and I will put in my MAC address table, and that's why you are seeing this MAC address, because the PC sent the gratuitous ARP. So this special GARP I'm going to show you now on live PC3. So no ping, nothing. 1.3, I will just assign the IP. I will just put IP address here 1.3, and he should send the gratuitous ARP, and go here, and we are capturing that link already. Okay, if any gratuitous ARP will go, it will just show us here. So let's go to PC3 and assign the IP. Okay, I'll show you your experiments later on. If you assign 1.2, you know what will happen? Bad things will happen. It will send gratuitous ARP, and this guy will send the ARP reply, and either your IP will disappear or immediately you will see the error message. Okay, so this is a good task for you. Okay, install GNS, set up switch, and try this on your own. If you do that on a router, you will immediately start seeing log, router, firewall, switch. You will see the log messages, duplicate IP address found on this interface with this MAC address. Okay, so let's assign the real one now, 255.255.255.0, and let's go here and look. Immediately you will see gratuitous ARP, and he is asking what is the MAC address of my own IP 1.3, and I'm asking my own. And if you open this packet, you will see the source IP 192.168.1.3, the target IP 192.168.1.3 also, source MAC my own 666802, destination MAC all times F, and this MAC address is going to be copied in the MAC address table 666802. Try to remember it, and then go here and look. This is not that MAC. That MAC is gone now, because if you don't receive any data after 300 seconds, that is 5 minutes, after 5 minutes it will flush down all the entries. So this is the new entry for your E02, and the MAC address is 666802, something like this, because it was learned with the help of gratuitous ARP. Okay, see, but the concept remains the same. Whenever any packet is coming to my device, I will learn the source MAC address. The only difference was you weren't aware of this magical invisible packet gratuitous ARP, which goes every time, even when you go to your own computer and you assign IP address. If I go here and if I assign IP to my Wi-Fi, immediately a gratuitous ARP will go to my modem. Best practice, if you have a modem at home, do one thing: connect two laptops via Wi-Fi onto that modem and assign the same IP on both of them. Within few seconds, don't send any data. Within few seconds, one pop-up will come and it will say duplicate IP address found or IP address conflict. Okay, so the mystery is, how can your laptop know without sending any data? Okay, so there is something that is checked for that in all the end devices, and that is known as your gratuitous ARP. Okay, so this was my motto all along, to teach you all these things and to tell you about this GARP also. So what do we have? You now know how switch learn about the MAC address. You know layer 2 and layer 3 switches also, and just few things, then we'll wrap up this session. We'll do a ping from PC1 to PC3, because we don't have PC1 MAC address, right? PC1 MAC address is not there. So let's just ping in from anywhere. You can ping from PC1 or from PC3. They will send the ARP request. Whenever you do ping from all the device, all their MAC address will be learned because they all will be sending some ping message or some ARP message or some packets will be sent. So let's delete these ARP entries. ARP story is done and let's hop on to the ping. So I want to ping 192.168.1.3. Let me see if I can show the ARP table. Show ARP. ARP table is empty. Meaning what? I don't know what the hell is 192.168.1.3. That's why my PC is going to send a ARP request, and using that ARP request the switch will learn the MAC address. As you can see, that switch right now don't know about E00. I don't know what lies after E00. But if I do the ping, our PC will send a ARP request to resolve the MAC address of 1.3 because PC1 simply don't know about the MAC address of 1.3 as I showed you in the ARP table. What is ARP table? It is a special place where you store IP address to MAC address mapping of all the devices that are in your network. Okay, in your network, not on the internet. Okay, because on the internet millions of websites are there, only of your local network. So I will ping and our packet will go behind the scene, our reply will come, switch will learn the MAC address of both source and destination, and that MAC address of 1.3 will also be stored in the ARP address table, as you can see right here that the MAC address of 1.3 is this, because I send a ARP request so to ask the MAC address of the other side. So I will go to switch 1 and you will see you will be learning the MAC address of both sides. And E02 was already there. E00 I learned because I send a ARP request. My PC send a ARP request. Okay, PC send a ARP request. This guy send a ARP reply. But no worries because E02 entry was already there, and I don't have the third entry. Why? Because nobody pinged that poor guy. If you go to any PC and you ping to the middle one, that entry will also be learned right there right now. 1.2. Just do a normal ping and you will see the switch will learn for the very first time the entry of 102 also. Okay, so one small thing I want to discuss, one internal working. This is all good, but what about the first time after receiving the packet on the switch? I am a switch. I received a packet. You told me that you came from 1.1. You want to go to 1.3. Your source MAC is something something. What? Let's take 01. Your destination MAC is 02. Now, for the first time, this MAC address. We'll see if this MAC address table is there. Life is happy. You know that okay, I want to go to E02 because this is the MAC address matching there, and I will just simply send that guy right there. But for the first time, as all of you know that this MAC address, I don't know how to delete this, but it is not there, it is blank. So now what? But you know that ping will happen, the data will be sent. So what switch do? There is a one special mechanism of switch that is known as unknown unicast. Unknown unicast means okay, you want to go to 1.1 with this MAC address. What is this MAC address? Something something 01. Actually, this full MAC address. Do I know this MAC address? No, I don't know. My MAC address table is empty. I'm a brand new switch. You just powered me on. My MAC address table is empty. So in that case, switch will do something known as unknown unicast, and in simple terms, it will just broadcast that packet to all the PCs. So whatever this packet is, it can be a ping or any other data, it will go, it is meant for this guy only. So when the packet will come, this entry 02 or this entry 01, the source will be stored here. But the switch don't know about 02. So I don't know what is 02, it is not there in my MAC address table for the first time. So I will do something known as flooding. I will send the data to everyone and this guy will receive it and he will say I am not him. I will drop it. And this guy will send a reply back because he is the 1.2 sorry 1.3. He will send the reply back and then his MAC address is learned. So this unknown unicast, this flooding broadcasting thing happens only when the MAC address table is not there, when you power on the switch. For the first time it will happen the switch will run the MAC address, and after that there will be no unknown unicast or no flooding will be happening, because after that the switch will be looking at the MAC address table and forward it accordingly. But in order to build that MAC table, the unknown unicast or unknown flooding and broadcasting will be happening. Okay, so that is all good, but you might say, what if a broadcast comes, then what? Because see, broadcast, the answer is super simple. In broadcast you will say I am 1.1, I came from 01 MAC address and I want to go to 1.3, and it is a broadcast. Just assume it is a broadcast. Okay, it's a broadcast at layer 2. The MAC address is going to be 12 times F. So what the switch will do, switch will see again, see, switch will do the simple thing. It will say, do I know f? Do I know 12 times f? Is it there in my MAC address table? You all know that it can never be in the MAC address table because it is a broadcast MAC. So that's why whenever any broadcast packet will come, the switch will always send it to everyone, because that MAC address of 12f if is never ever going to be in the MAC address table. Okay, that's why I broadcast will always be a broadcast. So if somebody asks you, will there be a time when a switch is going to broadcast a unicast packet, so the answer is yes. Unknown unicast for the first time, switch don't know what is the destination MAC on which interface it lies, so the switch will receive that unicast and send it to all the devices. It will receive the reply, it will build the MAC address table, and then after there will be only unicasting happening. So this is all about switches. This was a long session, but a lot of things we learned about switches. Last thing, as I told you, it is a layer 3 switch, but by default right now it is layer 2. So can I do this command interface? I don't know what are the interfaces, so I will do exit and I will do show IP interface brief. Oh my bad, show IP interface brief. These are the interfaces. So config T interface E00. As I told you, it is a layer 2 switch by default. For all the ports are layer 2 port, and you cannot assign IP address obviously because it is a layer 2 device. Layer 2 device don't understand IP addresses. They only understand MAC addresses. They learn MAC addresses. It is not a router. If you can do that, it means it is a router. Then you can also do routing. But you cannot do that because all the ports, even of a layer 3 switch, will be acting as a layer 2 port. All of them will be layer 2. If you want to convert them into layer 3, you have to do some command. And the command is not for the whole switch. Okay, you can't say, okay, I'm magically converting the whole switch into a router now. Then there will be a problem. Your switch will be either working as a switch only or a router only. But I want that, okay, some port, like for example, these two ports will only for routing, only for, sorry, switching. And in here, my topology is changed. I don't want this guy disturbing me, and I'm going to connect a router. I'm going to put a router right here. And if I'm going to put a router, then on that interface on both sides I have to have an IP address. So that's why you now will do what? You will go to this E00 and you will convert this single port into a layer 3 port. So this port will be acting like a router's port. So I'm going to show you how to do that. We are on the same interface E00 and you will do the command no switch port. The command is no switch port. I just press tab to complete it. Just do no switch port and then look. Previously you were getting the error message that I don't know what is IP address, and if you do it now, you have the IP address assigned, and this port is acting like a router's port. You can say that. Okay, IP addresses will be there. I'll turn it on and look. Show IP interface brief. This is now acting as my layer 3 port, and all of the rest are layer 2 port. So it's up to you. You can convert half of the ports, 3 ports, 4 ports. All depends how your topology is going to be. Okay, so this was all about switches. Watch the GNS video. be on track with the sessions. Okay, so I'll just stop the video. Hope you guys enjoy.